Okay, so what we're going to do now is we're going to do some examples where we're given a function f of x and we're going to find f inverse of x. So here's our first example. F of x is 23 minus x squared with the domain restriction that x is greater than or equal to 0 only. Now, you may recall this from a couple videos ago, and let's look at this graphically. We can see that 23 minus x squared does not pass the horizontal line test. But if we restrict the domain starting at 0 and going up through infinity, I put 100 here, but I mean that's just representing because we can only see so far. We can see now that this upper half of 23 minus x squared, it does pass the horizontal line test. And so because it passes the horizontal line test, we can identify the inverse of this function as a function. Okay, so what we're going to do here is we're going to rewrite it as y equals 23 minus x squared. And then what we're going to do is we're going to change all the y's into x's. Okay, so to identify f inverse, okay, what we're going to do is y's are going to become x's and x's are going to become y's. So we're going to write x equals 23 minus y squared, okay? And then what we do is after doing that, we solve for y. We just want to get y by itself, okay? And so the first thing I'm going to do here is I'm going to add y squared to both sides. Add y squared to both sides. And so now I have y squared plus x equals 23. And so now what I'm going to do is I'm going to subtract x from both sides, subtract x, and I have y squared is equal to x, 23. Do that again, sorry. 23 minus x. And now this y squared, we don't want to solve for y squared, we want to solve for y. So in order to make this y, we have to take the square root of y squared. And if I take the square root of y squared, I have to take the square root of the other side of the function. Okay? And so I'm going to take the square root of y squared, and then I'm going to take the square root of the other side. And here, the square and the square root are going to cancel, and all I have left is y, and I get the square root of 23 minus x. Okay? And so we will say that f inverse of x is equal to the square root of 23 minus x. Now let's look at this graphically. If we go back here and we type in y equals the square root of 23 minus x, you can see that, for example, the point 0, 23 is on this one, and the point over here is 23, 0. And there's a clever way that we can identify other points on these graphs, is we can put in a line called y equals negative x, and I'm going to make it actually negative x maybe plus 5, okay? Maybe now let's make it plus 2. There we go. And when we look at where this line intersects the green graph, we get the point negative 3.109 and 5.109. But down here we get the point 5.109 and negative 3.109. And so we can see that these two graphs do reflect being inverses. Also, one more thing is if we put in the line y equals x, we can see that they intersect at the point y equals x, and we can see that they appear to be reflections of one another over this line y equals x. All right, so now let's try where f of x is the square root of 2x minus 17. This is a one-to-one function. You can graph it and see for yourself. And so I'm going to write y is equal to the square root of 2x minus 17. Then I'm going to turn the y into an x and the x into a y. And now in order to solve this, I'm actually going to have to square the square root, and when I square the square root, I have to square the x squared as well. And so I get x squared is equal to, and this square is going to cancel the square root, and so I have 2y minus 17. Now I'm going to add 17 to both sides, and I'm going to switch it around. I get 2y is equal to x squared plus 17. Then I'm going to divide by 2 on both sides, and I wind up with y is equal to x squared plus 17 over 2, which can be rewritten as 1/2 of x squared plus 17 over 2. And now it's in standard form, okay? Now you may say, yeah, but you said, Mr. Ryan, you said that that x squared functions are not 1-to-1. And that's true. But I want to remind you over here that this function, the square root of 2x minus 17, has a range. It has a range of 0 to infinity. Okay? Let's see here. Including 0 and up to infinity. Okay? So that's the range of this function. Well, this is the set of all, the range is the set of all the y values, the output values. Well, if this is the set of all the output values, all the y values on f of x, then the set of all the input values on f of x is going to also be 0 to infinity. And so we can say here when x is greater than 0, meaning from 0 up to infinity. And now that it says x can only be greater than or equal to 0, now it's the portion of the graph that is 1-to-1. All right, so now we have this function x minus 4 cubed plus 7. So this is a rightward shift by 4 and an upward shift by 7. It's a transformation of the graph of x cubed. Well, the graph x cubed is a 1-to-1 function. We've seen it in a previous video. And so this is just a transformation of that graph. So we can identify f inverse of this function. And so what I do is I rewrite it with y equals, then I change the y into an x, I change the x into a y, and now this is pretty easy, which we just do minus 7 here, minus 7 here. We have x minus 7 is equal to, so this will cancel, is equal to y minus 4 to the third power. Now you may say, well, what do I do now? Well, what we're going to do now is we're going to do the cubed root to both sides. Cubed root, not square root, cubed root. So to cancel this third power, we use the cube root. So when we do the cube root of the third power, it cancels them. And now what we have is the cube root of x minus 7. By the way, cube root is 1-to-1. Is equal to y minus 4. And now if we add 4 to both sides, we're going to cancel the 4 over here. And now we have y is equal to the cubed root of x minus 7 plus 4, which is a 1-to-1 function. And so f inverse of x is equal to the cubed root of x minus 7 plus 4. Okay? Now let's say that we wanted to identify f inverse of a particular x value. So for example, let's say we wanted to identify f inverse of 15. Okay? Well, then what we would do is we would do the cubed root of 15. So we're going to put 15 in for x minus 7, and then we're going to add 4 after that. Well, 15 minus 7, that's 8. And so what we have here is the cube root of 8, which is 2, by the way, plus 4. So this is equal to 2 plus 4. And so f inverse of 15 is 6.